All right, it is 10 o'clock. We'll get started. So thanks again for joining. My name is Phil Belcastro. I am a customer application specialist here with Mintek Resources. Essentially your tech support. Anytime you call in, come to me for a question. I'll see if I can figure it out for you. So today we're going to be talking about our new product we're very proud of, our CQL, our construction quicklime. And with that, a couple housekeeping items. Throw your questions in the chat. The way I have things up right now, I can't see them, but I've got some folks in the back end monitoring them. And then at the end, hopefully I'll be able to duck out and see the questions. If not, Leanna or Kendall on our marketing side, they're going to help me out. And then PDHs, we're happy to provide them if that can help you out for attending. So get back to us after this if you're interested in receiving a PDH certificate, and we can work on that for you. So with that, let's get into it. We're going to talk about our CQL, construction quicklime. So I tried to, wonderful, why aren't slides advancing? See, my fancy clicker will work. Lovely. Worked a moment ago. Let's see. All right. So I tried to think about an honest agenda to put up there, but the bullet list I typically put up there just didn't seem to be kind of accurate and honest. So we're going to absolutely talk about drying, modifying, stabilizing. If you've ever joined any of our other webinars or lunch and learns or things like that that we're happy to put on, we're happy, and we always hammer home that our line products do that in the soil, right? So we're really here to talk about these additional benefits that we are seeing and realizing and very excited about on the CQL side. We're going to go through each of these individually, but at a high level, here's what we found. We can reduce the mixing. We're going to get better flow. We have increased spreading versatility. Reduced mellow is a huge one. Improved transfer rate, talking about advantages for our guys out there driving the trucks. And then accelerated early strength. And we can talk to exactly how we're finding that. So as we talk about quicklime, know that we've sold many tons of quicklime. We've listened to the market. We've worked with our engineers to get a tailored solution for this construction market. We're shipping out tens of thousands of tons per week, over 500 customers, about 30 states, primarily east of Mississippi and beyond, with Iowa and Louisiana. And of course, you've got some of those spot projects that pop up other places. But we've listened to what's going on out there, those pain points that, hey, quicklime's great, but, well, that's what we're talking about today. So with that, we are very proud to present our CQL, construction quicklime. So you spoke, we listened, at least we tried. All right, so what is different about CQL? Well, I'm actually here in the basement of the Innovation Center. I might take it down a notch for a moment. My engineers might be a little mad if I kind of oversimplify this a little bit, but really it comes out of this, it's finer. That increased fineness has let us have a increased surface area to volume ratio. So it's not necessarily the surface area, but the particle will still have now that we've decreased the size of those particles, that overall surface area to volume ratio is going to be more beneficial for us. So when those particles are broken down into smaller pieces, their overall surface area of that volume increases. And the surface area is a measure of how much exposed area the solid object has. And so if we look here at the chart, really as we approach the 50, 100, 200 mesh, we're about 2 times as fine. So if we kind of take a step back, look at this at a real high level, imagine a large cube. Now we're going to divide that cube into a bunch of smaller cubes. The total volume remains the same, right? But the total surface area increases because each smaller cube has many faces on it, each with its own surface. So if you continue to allow me to geek out a little bit, in chemistry, those reactions occur at the surface of the particles, and those smaller particles, higher surface area, they can react quicker because there's more area for the reactants to come in contact with each other, right? So what we found is that about 65% increase to that surface area to volume ratio. So along with the sizing that we did, kind of really rudimentary sieve testing, we did some surface area tests, and that's how we were able to come up with this 65% number. With that data, we were able to calculate, looking at midpoint diameters and surface area to volume ratio, weighting that, and that's how we came up with that over 65% number. So looking now to the benefits. So that's kind of how we did it. We made it finer. We kind of worked with our engineers to get the right sizing for us. But to the benefits, so the first one is that the higher surface area we talked about, that's going to help us out. This is one of the big ones that I'm very happy about, is reduced mellow. So I'm going to show a quick little video. It's a time lapse I did in the lab a little while back to kind of show how hydration happens and why mellow is a thing, and why some of those specifications that we see out there, we're challenging them. They're a little bit antiquated. In some instances, they're not a little bit. They're a lot antiquated, if that's even the right way to say that. So whenever lime is around water, we are going to start to chemically combine with that water. The hydration process is going to start. So I'm going to take some droppers. On the bottom, I've got my CQL. In the middle is kind of traditional quicklime fines. And then at the top is pebble quicklime, which for some instances, it is a good answer for maybe some projects that we can talk through maybe on a separate time, but primarily for dust concerns. It's a large particle. So as we're adding this water to it, you can see, especially on that top, the particle, that quicklime is almost like it's expanding, but it's like popcorn almost. You see it just pop open right there. So this is why mellow is a thing. In the soil, if we were to put those big pieces of quicklime in there, we have to allow enough time to let that water completely react with the quicklime in that soil and turn to a hydrated lime that is going to do the modification and stabilization for us. So let me see if I can back since I'm still talking. We can let that one go. I think it's gonna work. Yeah, nice. So what we've seen since we've decreased the size of those particles, we don't need nearly as much time as we once did, especially because we are also seeing a much better, some advancement in the equipment that we're using to incorporate the lime in the soil. Those soil reclaimers, they have a violent mixing chamber. They got those teeth in there. Things are happening. Particles are breaking down. We can inject water right in that mixing chamber. That hydration can happen essentially immediately, especially now with our CQL product that is that much finer. Those smaller particles are going to hydrate essentially immediately. So however, we've done the testing to see, conservatively, we're very comfortable to say that mellow periods can be as little as 4 hours, if not 2 hours. If not, we know we have people out there doing essentially a no period where we have reclaimers getting on it and the rest of the construction equipment essentially coming right behind it. So that's what we're talking about on the reduced mellow. It's now comparable to that Portland cement. Typically 3 to 4 hours after placing Portland cement, it starts to hydrate. You got to get it compacted. Well, now quicklime is in that same time frame, and that's helping us out on the mellow side, helping us out on the construction, the timing, helping to progress those projects. All right. Next benefit is accelerated early strength. So CQL provides earlier strength development, helping to give us that stable working platform that gives the contractors the ability to complete that work faster. So back to that surface area we talked about before, the smaller particles, increased fineness, higher surface area to volume. That's all going to help drive the reactions faster. If we're getting those reactions to happen faster, we're going to gain that strength quicker, helping to expedite that work. So giving us that solid working platform that we can keep the projects progressing. And in my webinars, presentations, I typically at the end, we talk data and case studies. Well, I'm going to hop into a case study right now because it kind of felt like the right place to talk about it. So a couple weeks ago, on the way to a conference, I was able to stop at a site where they were using the CQL. We were doing this for stabilization in Central Ohio, 5% rate. And my guys out there, they weren't waiting around for it. Got a quote down there from the site superintendent. He was pretty impressed. He said, the stuff looks like concrete. And I'm kind of censoring what he said. To be honest with us, he said he was a little skeptical, but he's a believer now. They're doing the next pad the same way. And what I mean by doing the next pad the same way, in the top right picture there, you can see soil reclaimer on the left. You can see some compaction equipment kind of in the middle. And on the right, in the foreground, nice solid looking surface, and they're putting stone on it right away. One thing about this project that was, I wouldn't say interesting, but I think it's at least worth pointing out. We're going to talk, I think, even on the next slide about reduced mixing. So here, as an insurance policy, they had the extra equipment laying around, maybe not laying around, but they had the manpower there to do it. In the bottom right, you can actually see 2 reclaimers. So soil clods kind of weren't breaking down like they had kind of hoped for after that first pass. So essentially, they had a train going, not quite right behind each other, but you have one reclaimer on one pass, the other one falling right behind it. They were able to do 2 passes kind of as an insurance policy. But here we were able to see true stabilization, getting the work done fast, minutes versus hours versus days that we actually see in some of those really antiquated specifications that we talk through with folks. Rather than waiting all that time, they were getting back to work, progressing that project and moving along. And I just like to see those tracks on the front left picture there. Okay, yeah. So next slide. Another benefit we're seeing reduced and improved mixing. So that is typically for across the soil types, 1 pass is all we need with those smaller particles. They're able to distribute a little better homogenization in the soil. So minutes later, with the proper hydration, we talked before about water trucks, possibly even directly injecting the water into the mixing drum. Maybe we have water present on the site. Maybe it's what we call a drying job, where Mother Nature has so graciously gave us some water. So maybe that's helping us out. But with the proper mixing, now the smaller material, we were able to see that improved and better homogenization with that single pass for most of the soil types. And that homogenization kind of comes back to this analogy like I like to use. Maybe a sugar cube versus granulated sugar in your coffee, tea, lemonade, maybe limeade. We're talking lime, right? So you picture that sugar cube is not going to break down nearly as fast and go into solution like the granulated sugar would. And that's what we've done here. Smaller particle is helping us out that way. Next benefit is on the sizing once again, for what we're talking about, but the spreading versatility, greater compatibility across a broader range of spread equipment. So keeping on that topic of equipment, the CQL at times, I'm not saying this happens a lot. Sometimes we've heard these pain points. Hey, we had that perfect size pebble. They got caught right in the flights or right in that special spot that jammed things up. And, we don't like to hear about that. No one likes to be the guy that's got to kind of dislodge that. Maybe folks on this call don't like to be the one hearing about the guys having to dislodge that. So we've kind of listened. The smaller particles, that's not going to be the problem anymore. No one wants to shovel that truck or that spreader truck out anymore. We've taken care of that with this. So we realize that many of the spreaders are designed for Portland cement. We know that our calciment LKD product can flow through those spreaders with that similar sizing. Now CQL has been flowing out of those spreaders really well for us as well. So going to our trucker friends, we appreciate their help out there getting the material from site to site or around the site. The improved transfer rate. We found that that the sizing helps to accelerate the transfer from the pneumatic to the spreader, decreasing the retention time. So now those truckers, those drivers are not waiting for hours to get the material into the spreading truck. They can work that tank pressure, they can increase the flow, and they can get back off the site, keep their hours down, or ideally, maybe they're making a turn for us, getting some more material back to the site so we can keep the project progressing, which we talked about a bunch. So increase that transfer rate. And it's a little bit similar, but I'm going to break it out a little different way. But the next advantage is better flow. So now we've got it going into the spreader truck. Now we can kind of use that full spreader truck. And for some reason, when I was putting this together, it's football time. Made me think of a Super Bowl commercial from a couple years ago. It was, I think it was Doritos, where The guy was on his lawn tractor and he was busted through the neighbor's fence. He was like, if you want the boy to throw 100 yards, give him 100 yards. Well, you paid for the full-size spreader truck. Now this CQL allows you to use that full spreader truck. So we're seeing that a full pneumatic can now fit into a full spreader truck. And that's because of this picture that you're seeing here. The finer particles are making their way back to the nooks, crannies, and corners, filling up that truck much more effectively, efficiently, better. We're not seeing that that the material clogging or plugging up the inlet line. So, and what this is going to do is, since we have all the material from the pneumatic in the spreader truck now, we'll eliminate that, what I like to call the extra trek. So the spreader truck, now it's full of material. It can go spread across the site. It doesn't have to come back to be topped off or to empty out that pneumatic. So we're saving some time there with that spreader truck having a full load. He can spread it on site and come back and accept the new load, or just move on in general. So kind of another two advantages there on the increased flow and the better transfer rate. So I went through them kind of quick, but those are the benefits we've seen with the CQL, with the finer sizing and the higher surface area to volume ratio. Reducing the mellow, we're challenging the norm there on some of those specifications. A lot of them we run into are quicklime must be mellowed for 24 hours. Great, get it, insurance policy. But now stabilization, you can get that compaction sooner, 4 hours, 2 hours, maybe 0 hours essentially. You're letting those bonds form quicker. You're helping those that strength get higher faster. And for stabilization, we're not breaking any of those bonds either. Lime is great with autogenous healing, something we talked about some other times where it can kind of heal itself. But if we don't break those bonds, we're allowing them to stay there. You can maybe get those higher, a little bit higher strength. Accelerated early strength, smaller particles reacting faster, help us get other equipment on that site sooner. Reduce mixing, single pass mixing is all you need for most soil types. If you got the time, the manpower, the equipment laying around. Second mix, never a bad idea. But back to my first point about the reduced mellow, I like that second mix if you can get on a little bit quicker. Let those bonds form. Modifications can be happening, but single pass mixing for almost every soil type is all you're going to need. Spreading versatility, wider range of spreader trucks. Those couple little nuggets that got in the right spot and lock things up, done away with that. So we're better across the board on spreader trucks that have been dialed in for other material, whether it be cement or the calcium and LKD products. Improved transfer rate, right on there with that. Maybe we're helping our truck drivers get off the site quicker because we're able to empty those pneumatic loads faster. Both of those kind of circle back to that reduced or eliminating that extra trek, helping the material get all the way to the back of that spreader truck, eliminating the need for that truck to come back to get topped off. So these are the benefits we've seen on the CQL. So with that, appreciate your attention to that part, but we're still Mintek. The CQL doesn't sacrifice on the essentials that Mintek has been proud to supply. So CQL is, in a way, I don't want to say it's still quicklime, but it is. It's still quicklime. We're still manufacture this to exceed those national standards, ASTM C977 and ASTO M216. Hey, they mirror each other now, part of the harmonization effects effort that was focused on making those specifications and essential tests the same. So it's still the quicklime we know and love, but now we're just made a little bit better. Like I said before, it wouldn't be a Mintek presentation if we didn't say dry, modify, stabilize, right? So we're still going to dry. Still going to chemically combine with that water. We're going to lock it up, creating the hydrated lime in the soil. Exothermic reaction, going to generate some heat. So cold days are coming. We're going to drive off some additional moisture in the form of steam. I'll stop there on the cold days. I think I'm coming back to that later, getting ahead of myself. There's something else popping in my mind about drying though. No, forget it. Maybe it'll come up later. So, hey, we're still calcium oxide, adding water, making calcium hydroxide. With the CQL though, now it's finer. Those reactions are going to be happening faster again. Maybe that's going to help us generate just that much more heat. and maybe that's going to help us drive off even more moisture, which could help us lead to potentially some lower rates. Now, maybe that's a 2.5% dose rate versus 3, but that extra 0.5% might help us add up over the site cost. Modify. What are we talking about on modification? We're targeting the clay portion of the soils. And that's going to help us increase those engineering properties, reduce plasticity, decrease, if not eliminate, shrink swell potential. And how's all that happening? Well, that's what you're seeing here in the mixing demo. Whoever made this video may need to hit the weight room a little bit, struggling with that bowl. So we got an 18 PI soil. This is a demo that we like to do live. Last week I did it live at a lunch and learn, and I think it took about 2 to 3 minutes for the thing to happen. We're going to speed it up here in the video, but modification on the site essentially happened immediately. So time lapse went real quick to 2 minutes there, and you can see the soil broke down very nicely for us. It went from those clay particles that tend to be negatively charged with a lot of water around them, lubricating things. You can imagine a load slipping and sliding, not very stable for us. They're in edge-to-edge orientation. And now that we've modified them, hopefully next animation is going to pop up. Let the video run. It didn't. I'm going to do a click, see if it comes up. Oh, bummer. There we go. Edge-to-edge orientation. Now we've had some cation exchange where our calcium has come in and pushed out other cations like sodium, potassium, and which has resulted in molecular flocculation and agglomeration. So what the heck does that mean? Well, we've changed those charges. It's not all happening equally at the same time. So we're rearranging those particles to edge to face orientation, and that rearranging is helping to give us friction. Friction is giving us some strength and bearing capacity. Also, you can see there in the little cartoon, less water around. So now we're not going to have that volume change, the shrink swell, if more water gets in that system. There's more area for water to kind of fill in those voids without sacrificing the compaction that we have on top of it. So again, CQL, we're going to be able to just do this faster. Smaller particles, increase those reactions, going to help us drive that. On the next slide, so I mentioned shrink swell potential. I look back at some of the data that we've produced here at the Innovation Center when we do our CBR testing, which is a confined test, but part of the testing, I think I got a picture actually, we soak this stuff for, ASTM has it a 96-hour soak. So kind of worst case, saturated, terrible conditions. What's that gauge doing? Maybe hard to see on the screen. Far left, there's some movement on the swell versus I think it's a 3 and 6% we were looking at on the middle and the right picture. Those gauges are staying at 0. So not only are we increasing the CBR bearing capacity, but we're also decreasing, if not eliminating, the shrink swell potential. So data here from Innovation Center, and I just was on the Google machine, and University of Kansas had a nice little study there too. So the table on the right, not tested. That's why I wasn't able to find the PI. So on the modification side, we are able to drop the PI as well. So you can see some of the untreated PI. My eyes hopped to that 88 down to a 13. So pretty impressive drops that we can see here with our CQL and quicklime in general on improving those engineering properties, dropping the PI, reduce, eliminate shrink swell potential. So we're going to accelerate that working platform. We talked about the CBR. So here's a couple we've tested, fat, lean clays, some others mixed in there, but low CBRs to start on the brown there, the untreated, versus essentially immediately the treated CBRs. 4 hours later is when we tested them. You saw how quick it's happening in the bowl. Those CBRs increased, 2, 3, 4-fold at times to something much more desirable to build on. So that's what we're seeing in the before, during, after. A couple hours later, those folks are drying the site. You're getting the additional benefit of modification. And with CQL, we're doing it faster, right? Maybe preaching, hammering that home. The sizing the sizing helps us make this happen faster. Additionally, since those reactions are happening faster, maybe this is going to help us lead to some lower addition rates, that is. So increase the building bearing pressure and resistance. Took those same CBR's numbers, or CBR specimens, put them in our cure room for 7 days at a higher temperature to mimic a 28-day is what we're seeing here break. So you can see that we started at 4, 6, maybe 10, and increased that to some really impressive strength. And again, with CQL, that single mix, faster reactions could ultimately lead to lower dose rates and getting that. So here we're not necessarily looking at the building platform that we touched on previously, but here we're looking for that ultimate strength. Maybe this is something we're going to incorporate into pavement design. Hey, we're building an Amazon that's got robotics that can't shift anything more than like a 1/16 of an inch, something crazy. We need some true stabilization on this site. So here's where we're looking for that long-term strength that lime can help us realize. So mentioned football before, throw this up. We can help to eliminate, remove, and replace. And a couple years ago, I did a lunch and learn closer to Super Bowl time. Didn't know the size of the project, so I brought it back to the size of a football field. But this owner, for whatever reason, the engineers couldn't relay the facts to him, or he wasn't a believer. He just couldn't take it in. He went, instead of chemically treating, he went with the remove and replace. So he brought in over, I think the math worked out to over 60 trucks. If this was a football field, I think the site was a little bit bigger. 60 trucks of fill material to build this up a couple feet, rather than at an average rate, 3%, maybe 4%, would be about 3 to 4 trucks of the CQL. So we can eliminate that need for the remove and replace. You've got soils that are not very desirable, we'll say. Those clay soils, maybe they're wet, and get it. But when I go to the sites, I'm one of the few people that are smiling because I know that clay soil is primed for lime. We can modify it. We can get some true stabilization on it. We can use what Mother Nature has put in that soil, the natural pozzolans, silicas, and aluminas, generate those bonds that we're going to use to generate these needle-like cementitious and pozzolanic reactions for us. Getting close to the end, I was talking about heat before. Getting colder out there, lime is exothermic. We're going to generate that heat. Well, the CQL, it's finer. We're going to generate that heat quicker. Maybe we're going to generate more of that heat, going to help drive those reactions. So a couple things that are advantageous for us that we have in cut sheets that are available on our website, or just reach out. We're happy to get them to you. Come up with some tips and tricks on the cold weather side. And one of them is, hey, that exothermic reaction, maybe you're working on a sandier soil, more granular, that's a little more conducive to cement. Maybe you're not quite the believer for some reason in lime yet. Let us get out there. We can dry that soil. We can generate some heat with the lime. If it's the clay soil, maybe we can prove to you that lime really is the answer. Happy to do some of that testing here at the Innovation Center. But that extra heat, we can allow the cement stabilized soils to cure as they would in warmer conditions. Especially when we're working in lifts, kind of have that nice warm blanket of soil on top, insulating it. So got a bunch of those tips and tricks, but once again, CQL, it's finer. It's going to generate those reactions and that heat faster and potentially higher. So of course, we got other tools out there. Mintek Resources have many of those resources. One of them is this handy cut sheet. Usually have one with me. Backpack's a little too far away. Have laminated ones, happy to hand out, but this is available on our website. It's a nice soils guide to kind of show you what products might be more conducive to you. Talking about cement and granulated soils, right product for the right project. Mintek's not going to push lime on you in a sandy soil that's going to fail. That being said, we've done some testing where we thought maybe lime wouldn't be the answer, but we got some good results. So I love doing the tests. Me and my boss, he's still on the call, Craig Ass, we talk about it all the time. Test is worth 1,000 guesses. So ever in question, get with us, get some soil samples. Happy to prove it out here at the Innovation Center. On the soils guide, as we move to higher PI, higher clay on the right, that's where the quicklime and now CQL can really work well for us for stabilization. And then we've got our calciment LKD product that kind of bridges the gap between. That product brings pozzolans to the table, so it kind of supplements what we're missing out from cement or what Mother Nature gives us with the silicas and aluminas in the clay. It kind of brings some of that to the table so we can kind of bridge the gap between the two. And then that blue box at the bottom, all day, every day, lime products going to be a great drying solution for us. Moments before this call, I was just on a call from a guy up in Michigan. Hey, we were using what was he using? Sawdust. And someone maybe came to the senses a little bit and saying, hey, we're not going to allow you to do that anymore. Come to Mintek. Yeah, of course we can help you dry that material. Let's talk about another time. We can talk through what we're going to do, but all day, every day, the lime products are a great drying solution for you. So with that, that's all I got. We talked about the benefits of lime in general. Now we've got the increased benefits of CQL, reduced mixing, better flow that's going to help us on the spreading, better spreading versatility across different trucks. Reduced smell is a big one. Accelerate early strength help us get to work. All that in conjunction with dry modify stabilize that we're proud to be built on is going to help us save money. And now with CQL, we're hoping that we can help you save even more money. So with that, I'm going to try to mess with my screen a little bit so I can pull up some of the questions that we might have, and we'll go from there. So you might see my nice little background, my paradise here, my beach, and I'm going to pull up some Q&A, and maybe I would just stop doing this. And let's see what questions came in. Let's see. Nick, appreciate you hopping on. Let me read through your questions real quick. Let's see, a lengthy one. So we'll just do it live, right? So Nick D, how's it going? He's saying, I assume the owner or general contractor allowed the placement of stone sub-base while the subgrade was still in the cure period. I think you're talking about the case study I was talking. Was that based on previous experience using CQL? Was there compaction requirements during testing, or the proof roll situation? Nick, I believe it was compaction. I didn't see anyone out there doing proof rolls. They got proper compaction, and they were not allowed to do it based on previous experience, because this is one of their first times using the CQL product. But it was right there in your backyard in the Ohio area, and I believe that they were getting the compaction. They were seeing it, not necessarily in proof roll, but we saw the picture of the tracks, so they were seeing it not pumping on the site. So Tim, if you're on Central, well, now you're our sales manager. Tim Chillick, do you have any comments on what our folks out there how they were able to progress and prove it that way?
I do not have an answer for that, but Nick, I can talk to you offline on that and find out more information.
Yeah, I'm pretty sure they were getting the density they were looking for. And then another question from you there, Nick. Have we done lab testing? Absolutely. Traditional quicklime versus CQL. Yeah, we tend to see that a little extra bump. And then we've also done some with the dole mixing versus not, and same sort of thing. If we're not breaking those bonds, we're seeing that little extra bump. And that's why we're excited to say that better working platform, we're getting those reactions faster, quicker. Can it lead to lower dose rates? We think so, but it's not going to be a 5% down to a 2% sort of thing. Maybe 0.5% if you can meter that incorrectly. But I think it's really, if you're using the same prescribed specified dose rate, we're hoping what we're seeing is you can get on it quicker using this finer product.
And we can share that data with you as well. So if Bill, if you want to connect with whoever's recording,
Nick and whoever, we'll try to.
It's good conversation is the best way to walk through it versus just sending and posting data. Yeah. It's nice to see the talk to the why of what's happening. So,
Mike, I see your question. How is the percent lime to be used determined generally? So I think what you mean is, hey, how do you figure out the dose rate? I guess it depends. Drying applications. I don't know about where you guys are. I'm based in Pittsburgh. We finally got some rain over the weekend. We needed it. So, hey, it just rained for a couple days. My site's a soupy mess. Tim, my other sales guys, hey, let me get a couple loads of quicklime. I'm going to meter it out. Drying applications, 1 to 3% ballpark. is 2% not doing it? Let's put that extra percent down. Yeah, it looks good. It's those tires on their claimer they're wet, but the material's not sticking to it. It's a nice little guide. You know, you're kind of getting close to that optimum. So drying, you're not doing any lab testing is a long-winded way of saying it. Modification, hopefully we've got time to do the testing, and maybe on the modification side, a geotech out there is saying all of your engineered fill or your subgrade material has to be lower than a 20 pi. I've got this 25 pi soil. I like to throw this out. Please no, let's improve what you already got there. Hopefully we've got time to do it. We can do some PI reduction, and we can prove that we can drop that material down to an acceptable level with some Atterberg limits and reclassify the soil afterwards. So that's how I would see what dose you needed if you were on the modification side. Maybe it was a shrink swell criteria as well. Maybe 2% doesn't quite do it. Maybe 3 or 4 does. But lab testing is absolutely important for stabilization. So we're going to do in the lab, we're going to do the Eads Grim test, which is ASTM 6276, the minimum lime content for stabilization. So, hey, at what point are we getting to the right pH where we're going to solubilize those silicas and aluminas, make them available to make the calcium aluminate hydrates, calcium silicate hydrates, CAH, CSHs, same sort of reactions that are working with cement and concrete. Those are those pozzolanic cementitious bonds. So at what dose rate are we at that point where we're going to get true stabilization? Glassed over some general dose rates. Drying, I mentioned 1 to 3. Modification, I kind of bump things up kind of 1%, but it can vary. So 2 to 4 in general. And then stabilization, 3 to 5, maybe 6, rarely 7. But I know my lab guys, if anyone has ever had the pleasure of working and talking to Steve Satoki, he's like, why am I doing this test? It's going to be 4%. I can tell. Almost all the time, it's around 4% for true stabilization, maybe 5. So that's kind of my range, 3 to 5, maybe a little higher. But lab testing is absolutely important for stabilization. So long-winded answer there. Lab testing is important, not so much for drying. And we're going to do that dose rate. We typically relay it as a dry, based on the dry weight of the soil. Jonathan, hey, how does the cost compare to cement? Great question. Always comes up, right? That's why I like to have Tim and the other sales guys on the call. I'll let Tim speak after I'm done rambling, but it depends on the location of your project, the availability, what we got around. So we have CQL in a couple spots. Our main production area is coming out of northern Kentucky, just outside of Cincy. So you figure where that material can go. However, please let us know where your project is, because I know Rusty, for example, he's railing it down to a terminal just outside of Charlotte. So we can work to set up terminals and get it where it needs to be. In general, it's comparable, probably a little under cement, knowing the cement varied over the last little bit was, well, we're past COVID now. Let's stop talking about it. So with that, Tim, I'll let you maybe speak to it, but comparable would be my short answer.
Yeah. On a per ton basis, it would be comparable to type 1 Portland cement pricing. So it'll just be case by case. So if you have an opportunity, please bring it to us. We can look at it, look at our network, and we can develop competitive pricing for each particular job. But from a broad standpoint, ton for ton, same cost.
All right. I don't see any open questions at the time. Last call while we're waiting. Appreciate you joining, talking CQL. I know I went back and preached on the tried and true dry, modify, stabilize. CQL is still going to do all that stuff. We're just going to see it doing maybe better, faster, help you get a little stronger, a little quicker. So very happy about the CQL product. Very excited. Listen to the market out there. Thought about the pain points. Worked with our engineering team down here. Made it finer. Increase that service to volume ratio, and hopefully it's a nice product that we're pretty excited to get out there in the market, and continue to see some of those results that we saw there in Central Ohio. So with that, once again, let me know if you want some PDHs. Thanks for joining, and sign off for now. Thanks, everyone.